Gigo.
Hello everyone, I am Teacher Raccoon. Today we're going to look at the crazy timer from lesson 4. Here are the components. This model is basically like an alarm clock. We can set the time and then get it to perform an action. This one only uses 2 motors. The motor is used to drive the wheels. Similar to the powered tram, there is also a new component, the belt. Pair the tires with the belt to make the model move. You will find that it actually uses very few sensors. The program is very important for this project. As you can see, the parts are very simple. Let's build the model. Okay, we've completed the crazy timer now. It looks like a car, right? You may wonder why it looks like a car. This is related to a special function of the alarm clock. When the alarm goes off, it will run around, and you'll have to catch it and turn it off. There's also a countdown function in the program. If you press the right button, it adds 10 seconds. Pressing the left button adds 1 minute. So this is a countdown alarm clock, and when the timer runs out, it will run away. To do this, the program will be a bit more advanced. It has to control the time and motor variables, so that it always moves differently, otherwise it will be too easy to catch. This model uses this green monster card as a switch. Once it rings, you have to scan the green monster card to reset it and turn off the alarm. Let's get started. We'll start doing some programming, but follow carefully because this one is a bit more complex than before. It has a lot of variables. Don't worry though. We'll go through it step by step. First, click Board and add the Use Wi-Fi to Control block. Update your device ID. Click Gigo and then add the DDM motor stop block. We'll use 2 motors. One is pin A on the right. The other is pin E on the left. Pin A is the right motor and pin E is the left motor. To begin, let's set both motors to off. Next, set the first variable by clicking Variable, then Create Variable, and then enter T as its name. Next, add the set T to block. Then, click Math and add the 0 block. Change the 0 to 10. Why 10? Let's talk about what the T variable is. T will be the number of seconds in the countdown timer. So in the beginning, we have to set the countdown time to 10. Then it has a time buffer, where more time can be added, or it just counts down from 10 seconds. After this, we will assign the green monster card for the off action. Click Object Tracker and add the Set Model block. Create the little monster categories, so it knows that there may be different situations. For this model, we'll use the green little monster to swap modes. This bit is similar to some of our other models. We have turned off the motor and created the little monster categories. Let's try to control the time with the right and left buttons. Click button and add the when button L is pressed, do block. Copy the block so that you will have 2 blocks, one for each button. Pressing the left button will add 1 minute. Pressing the right button will add 10 seconds. Click Variables, then add the variable increased by block. Change the value from 1 to 60, so that when the left button is pressed, the time will add 60 seconds. Then copy the block and change the value from 60 to 10. For now, at startup, t equals 10. Pressing the left button will add 60 seconds, so the total will be 70 seconds. Pressing the right button will add 10 seconds, so the total will be 20 seconds. One button adds 60 seconds, the other adds 10 seconds. Next, we'll complete some other parts of the program. Add the repeat forever do block, but don't click the sync. We'll be adding lots more programs. Think about how many situations your bot will encounter. Situation 1, the timer has not run out yet, so it needs to count down. Situation 2, the timer has run out. The servo motor will trigger and it will make a sound. Click on Logic and add an if do block. It needs to confirm what the value of t is now. Then perform the corresponding action. Click Logic and add an equal block. Click Variables and add a t block. If t is less than or equal to 0, then execute the program we are about to write. Click the gear icon and select Else. It means the variable t is greater than 0. We will complete the alarm clock program first, and complete if t greater than 0 program. Because this program may be a bit more complicated, first I'll explain all the properties of the t variable. It will be easier to get started when you understand all the programs. If t is less than 0, then the time is up. Otherwise, the clock will wait. So what will it do before that then? It needs to start a countdown. How can we make it count down? Particularly, we want it to count individual seconds. This bit is very simple. Copy this block, then change the value from 60 to 1. But we have to add a dash in front of the value. Positive numbers mean an increase in time, so a negative number mean a decrease in time. No, it counts down 1 second at a time. Next is the more important part. We click Loops and add the waiting 1 second block. This means that it deducts 1 second every 1 second. Let's review the program. First, turn off the DDM motors, and then set t using the left and right buttons. The initial value of t is 10. Because 10 is greater than 0, it will execute these programs to decrease time. It will execute this section until t is less than or equal to 0. We'll finish those programs later, because we still need to add a bit more code below. We'll tell the screen to display the current countdown remaining. Otherwise we won't know when the timer will run out. Click LCD screen, add the Clear LCD Views block first. Next, add the LCD Draw Text block. Here you can adjust the size and spacing of the text. Remove the hello greeting, we don't need that right now. Click Text and add the Create Text with block. After putting it in, we'll create 2 paragraphs of text. One is minutes and the other is seconds. We will put a colon between the minutes and seconds. It'll look like an electronic clock. Click Math and add the round to the decimal point 0 block. This part gets a bit more complicated, because Webduino is frequently updated. When we were designing the program, it was preset to be unconditionally discarded, but after the latest update, it now rounds to a decimal point. So here, we will suggest or use unconditional discard, which is the previous version. How can you find the previous version? You can download the sample program from the Dropbox link. It will have a block from the previous version. Because if you use the updated version, it will have a 0 after the decimal point. That means there is no way to accurately display the remaining minutes. I'd suggest using the previous version if you can. The unconditional discard is useful. Let's continue. Click Math and add this block. Change the plus to divided by. Now it will show the time first, which is the variable t. The variable t is divided by 60, so add the 60 block. If variable t is 60, then 60 divided by 60 equals 1. So it should show 1 minute. If the variable t is 80, 80 divided by 60 is 1, remainder 20. Because we use unconditional rounding, it displays 1 minute. Click the blue gear icon and pull the item below. Note the colon in the middle to separate the terms. Next is the seconds. Click Math and add the remainder of block. This tells it to display the remainder of the two numbers. Put in the t and 60 blocks again. This will display two number blocks, one will be minutes, the other will be seconds. Take 60 as an example. 60 divided by 60 equals 1, so it will display 1 minute. The remainder of 60 divided by 60 is 0, so the second will display 2 zeros. If the variable t is 80, 80 divided by 60 is 1, remainder 20, so it will display 1 minute and 20 seconds. 80 minus 1 becomes 79, so it will show 1 minute and 19 seconds. Let's review the program. Turn off all motors. Set t using the left and right buttons. Variable t starts with a default of 10, i.e. greater than 0. It will begin a countdown and display it on the screen. Once it reaches 0, it will execute a program that we haven't input yet. So it executes this program first. It will execute when t is less than 0. These are all the programs related to the t variable. You can change the position of text here. You can pick the values you prefer. I just used the values from the sample program. Well done, we completed the t variable part. Now let's write the alarm clock program. The timer counts down from 10 seconds. Or you can add time by pressing different buttons. Either way, it will eventually count down to 0. At 0, it will start to make a noise. But before that, we wanted to perform a recognition action using the green little monster. Click Object Tracker and add Start to Recognize block. Do you remember the little monster program from Lesson 1? This will be almost the same. Add the Set Obj group to block. This obj group has the green monster variable. Add the if do block below. Copy this block and delete the variable block. Click Lists, and add an array variable, the length of block. Change the variable to ObjGroup. If the ObjGroup is greater than or equal to 1, this means it has detected the green little monster. All programs reset if it detects the green little monster, just like a switch. It will reset to its initial state. So the program is pretty simple. Put these programs again. Situation 1, it detects the green little monster and stops. Situation 2, the time is up, but it doesn't detect the green little monster. Click the blue gear, then pull the else block in below. Let's program the alarm block. We can add some randomness for fun. Recall, we said that the alarm clock will be running around, so we can't predict which way it will go. Create a new variable random. And then add a set variable to block. Click Math and add the random integer from 1 to 100 block. Integers are whole numbers, so it cannot produce partial numbers, like 1.2, 1.3. Here we change the 100 to 2. Now, once the time is up, if the model doesn't detect a green little monster, it will randomly pick a variable, 1 or 2. Select Stop Motor to avoid an accidental run. And add a 0.005 second waiting time. Click Logic and add another if-do block. Copy this block and move it to here. Change the program to if random equals 1. Now we can write different outcomes for outputs 1 and 2, and let them execute randomly. If the output is 1, then it should move forward. Let's check the model first. The motor on the right is pin A. So when moving forward it will rotate clockwise. Motor E on the left rotates counterclockwise. To move forward, the direction of rotation must be the opposite. Let's back to the program. Click Gigo and add 2 DDM motor blocks. Instruct Motor E to rotate counterclockwise and Motor A to rotate clockwise. Now we need to create another new variable. So now you see why this is getting a bit more complex. We need to create 2 variables, one is speed 1 and speed 2. What do these do? You can think of these as the maximum value of a speed. Add the set speed 1 to and set speed 2 to blocks. Speed 1 will be for motor A, and speed 2 will be for motor E. Next, copy the random integer from 1 to 2 block. Change the values from 1 and 2 to 70 and 90. This is the maximum speed of the two motors. Does this sound complicated? If you don't see what we're doing now, in a few minutes, you'll see why we need the speed variable. So we looked at the situation where if the random is 1. So now, click blue gear and drop the else if in below. The programs are similar to the previous ones, so you can just copy these blocks. Change it to if the random is 2. Now, set motor A to rotate counterclockwise and motor E to rotate clockwise. To stop it going too fast, we can put speed 1 and speed 2 in again. But with a range of 40-60, not 70-90. That way, it won't go faster than 60 if it goes backwards. And it won't go faster than 90 when it goes forward. After setting this up, we need to create two functions. First is ddemma, which means that this is the function of motor A. Second is ddme for motor E. Now we have two functions, ddma and ddme. We'll put the program in both functions later. Click Functions and add the ddemma and ddme blocks. We have decided the direction of motors here, so now we have to add power to the motor block. Let's review the functions quickly. A function is a bit like a package, it can only perform one action at a certain time. That's why we created the special ddma and ddme blocks, to contain everything. Except for the motor, we have almost finished setting the rest of the programs. Now we can finish the rest of the program. The logic is very simple. If the timer is going to wake people up, it has to make a noise. Click Speaker and add two blocks. First is volume, which we set to 100, which is the loudest. Change the file name from logo to by. Make sure it's all lowercase, because this is related to the sound file on the SD card. We can set the sample rate to 50,000. Copy the block to make it by twice. Then, copy the two DDM motor stop blocks so it can stop properly. Before we write the program functions, let's review what we have so far. If t is less than or equal to 0, it will perform an object tracking task and use the little monster to determine whether the alarm clock should operate. If it doesn't detect a little green monster, it will start the motor and make a sound. Then, if you're awake, you have to show the little green monster to prove it. When the little green monster is detected, the length of obj group will be greater than 1, so it will stop immediately, and reset to the initial state. Okay, let's finish the program functions. First, click Gigo and add a DDM motor speed block. Next, click Loops and add Count with I, from 1 to 10 by 1 block. Click Variables, and create two new variables A and E. This is the final motor value. Copy this block, pull it into the DDME function. Now variable A will count from 1 to 10. We delete the two 10 blocks and change them to speed 1 and speed 2. Next, pull the motor program into the DDMA function and change the speed from 60 to variable A. To copy this block, pull it into the DDME function and change the variable E. Let's look at the logic here. The variable random will produce either 1 or 2. And when it is 1, the model will move forward. This leads to the variable speed 1 and speed 2, which are also random. If it returns 90, then that value is passed back into the function, and variable A will count a value from 1 to 90. But what does by 1 mean? That means it adds 1 every time, and then goes from 1, 2, 3, for all the way up to 90. So the final speed of the motor is based on variable A. How often does it add the value? Well, we can control that. Click Loops, add a waiting 1 second block, and change the value from 1 to 0.005. So it starts out with a velocity of 1, then every 0.005 seconds it adds 1 to the value, so the speed becomes 2, which is basically an instant process. However, the accumulated maximum value is 90. The end result is a random speed we can't predict. The range could be from 1 to 70, or from 1 to 90. So there's a lot of variation in the speed. Now you have to be fully awake to turn off the alarm. Of course, the DDME function is very similar to the DDMA function. Just make sure to change it to motor E and variable speed 2. Now we have completed all the programs. Let's do one more review. First, stop all motors. Set variable T to count down. Create the little monster categories. Pressing the left button will add 60 seconds to the timer, and pressing the right will add 10 seconds. Next, there are two possible situations. First, if the variable T is less than or equal to 0, it will execute a given program. Second, if the variable T is greater than 0, it will continue to count down in seconds and show the time on the screen. Remember to use the sample program to get the previous version of this block. Then it will round it to the decimal point more easily. When the time is less than or equal to 0, the time is up. It will look for a little green monster. But if it can't find one, then it will return two values. 1 is forward, 2 is backward. Both of those will return a random value for speed 1 and speed 2, where speed 1 and speed 2 are the maximum motor values. For example, if the variable random is 2, the backward program will activate, and if speed 1 and speed 2 are 40, then the speed will increase stepwise from 1 to 40. It increases by 1 every 0.005 seconds, so going from 1 to 40 will only take 1/5 of a second. If I want to turn off the alarm clock, I need it to detect the green little monster. If it detects the little green monster, both motors will stop, and the variable t will reset to 10. This is the initial state. Because variable t is 10 by default, it will begin counting down again. Okay, these were all the programs for this project. Looks a bit complicated, right? Well, there are a lot of variables. If you understand the meaning of each one though, you'll soon be writing your own programs. Let's send the program to the device and see it in action. Let's turn on the power and start the test. There it is, counting down from 10 to 1. When we press the right button, the time increases by 10 seconds. When we press the left button, the time increases by 60 seconds, which is 1 minute. We also designed a program to display minutes and seconds, just like an electronic clock. When the time is up, it will run away while making a noise. So you can adjust the time you want by pressing the left or right buttons. Our time is almost up. Let's see what it does. You can hear the beep sound. Because of the variables, it goes forward or backward at random. It also moves at random speeds. Now we can put the little green monster in front of the camera. It has gone back to countdown mode. This was the Crazy Timer from Lesson 4. Thank you for watching.